All right, I wanted to show you one more example. This will be helpful for you when you're working on the homework. You'll be asked to work out these kinds of problems. So this time, I give you the second derivative, and I tell you not 1 but 2 points on the curve. So f of 0 is 4 and f of 1 is 1. And so let's see if we can recover f from the second derivative. This is actually a form of what's called differential equations. You'll learn some more about this in Calc 2. There's a whole class on differential equations. It's really very much a huge application of calculus. It's all about recovering original functions from equations involving their derivatives. So this is a kind of a straightforward sort of differential equation, but we're going to work it out. So given f double prime, I know that f prime is going to be an antiderivative of f double prime. So I'm going to get 12x cubed divided by that power plus 6x squared divided by that power minus 4x plus c. Simplify 4x cubed plus 3x squared minus 4x plus c. All right, that's f prime. Now I'll just circle that. Now I'm going to go ahead and compute f. So f of x is going to be the antiderivative of f prime. So I'm going to get 4x to the fourth over 4. You can just cut right to simplify. I'm trying to show everything. So 3x cubed over 3 minus 4x squared over 2 plus cx plus another constant. Let's call it d. These constants need not be the same, right? This constant came from the antiderivative of f double prime. This constant came from the antiderivative of f prime, and so they need not be the same. Well, now we're going to use those 2 points that we've been given. So, for example, I know f of 0 is 4. So 4 is f of 0, but when I plug 0 in for x, I get 0, 0, 0, and 0. I'm left with just d. Well, that's great. Now I know that d is 4. So I don't want to rewrite all of this, but let's just copy this part, and we can say, so then what? We have that f of x is all this plus cx plus 4. And now we can plug 1 in, and we're going to get out 1. So I know that when I plug 1 in, I should get 1. Oops, I didn't cancel everything. So this is just 4, this is just 3, and this is just minus 2. There we go. That's much better. Plug in 1, and we get what? 1 plus 1 minus 2 plus c plus 4. And it looks like all this is equal to 1, right? All this equals to 1. So these cancel. So I get c plus 4 is 1. So it's pretty easy to see. Let's write that down. C plus 4 is 1. So c has to be negative 3. And so finally, I can actually write down the complete function f. F is x to the fourth plus x cubed minus 2x squared minus 3x, because the c goes with the x, plus 4. And so that's how you can recover a function from its second derivative given enough information. So let's go ahead and peek at the next section, but I won't do another example. We'll end this video in a minute. So where we're going to go with this is we're going to look at what's called rectilinear motion. This is motion on a straight line. So maybe you've got this here. Let's draw a line. We'll do a vertical and a horizontal. Maybe you've got like a car, and you're on a straightaway. And so you're going to start here, and you're going to go there. That's motion on a straight line. Maybe you can certainly go forward and bounce back and forth. Maybe you've got like a ping pong ball bouncing between two walls. That's motion on a straight line. Maybe you're going to drop a rock from the top of a cliff. Maybe you're going to shoot an arrow straight up. It's going to go up, 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 slow down, and then fall back down. So any kind of motion that happens on a straight line is what we're interested in. And so just a couple of things. If an object has position on your line, s of t at time t. So just to be clear here, s of t is telling you how far you are from some sort of key point. Your key point might be the starting point. So then if I said s of 2 is 1, what I mean is after 2 seconds, you are 1 foot or 1 meter, 1 mile, whatever unit you're using, away from the starting point. And you've got to indicate a direction, so on and so forth. So for us, usually on a horizontal line, positive direction is going to be going to the right, and the negative will be going to the left. And then the same thing vertically, positive is up, negative is down. So anyway, in this situation, if you have a position function s of t that tells you where you are at time t, then the velocity of the object is the first derivative. It's v of t equals s prime, and the acceleration of the object is v prime, which is s double prime. So the second derivative of the position function you can think of as acceleration, the first derivative as velocity. Kind of fun. So I thought we'd end this video series with 2 examples and just play around with those things.